Hello, once again, I'm Bart Massey. Welcome to Introductory Programming in Python. I want to talk this time about one of the concepts in computing so important in programming that's so important it has its own name, input and output, which is often abbreviated to I/O or just IO. So IO is a big deal. And the idea here is that once we get beyond typing things at some kind of read, evaluate, print loop, and start using stored programs, we really need to have a way to get user inputs into our program and get program outputs back to our user. And that's what we're going to be looking at today. And the way we do output, we'll work from output to input. Output is done using the print function. We talked a little bit earlier about functions and how you might call them. The print function takes sort of any number of arguments, and each argument is an expression, and it will print those arguments onto output and start a new line. And that's all there is to the print function. It's not anything super fancy. It's just a way of getting output onto the screen. So let's take a look at that in mu here. Let's get a read eval print loop, and let's type a thing at it. So if I type 3 plus 5 at this, it says 8. If I type print 3 plus 5, it doesn't look very different. It says 8. If I say print 3 plus 5 and 4 divided by 2, it's going to print 8 and 2.0. And why the 0.0? Well, because when you do division in Python, you get a fractional number instead of a whole number. And so that's the print statement. And in this context, in the read eval print loop context, it's not useful really to have this, right? The printing things doesn't really do anything. But as we saw earlier real briefly, where the print thing comes to its own is in stored programs. If I write a stored program that prints 3 plus 5 and 4 divided by 2, then if I just put 3 plus 5 itself as a program, let's see what happens here. 3 plus 5, and I run that program, and it asks me to save first. We'll call it io.py, I guess. You can't use the file name io.py. See, it's so important it has its own name and everything. Let's call it iodemo.py, which should be safe. So now I got my thing here, and after some careful management, I'm going to just escape out of this because it's driving me nuts here. If I pop mu up here. Now, if I run this, what does it print? Oh, it doesn't print anything. It literally just doesn't print anything. Well, why? Well, because unlike the read eval print loop mode, the stored program mode, you haven't told it to do anything. It computes 3.5 quite nicely. It doesn't print an error message or crash or anything. It just says, okay, I printed 3 plus 5. What did you want me to do about it? But if I say print 3 plus 5, then all of the sudden I'm going to find that when I run that program, what I get is 8 printed on the console. And yeah, the spacing here is a little weird because we have both these things going at the same time, but you can see here that when it ran and produced 8. If I run it again, it will print 8 again, and apparently put the spacing back because of course it will. And so now every time I run it, it will output that output, and then it'll print a new line. It'll go back to the beginning of the line afterwards, and that's where it'll be. We can see the same behavior if I try to run this at the command line. So let's save our little program here. Save, and then let's go to our terminal here. And if I go, there we go. Python 3 io demo.py, it runs the program and the program prints 8, just like you'd expect it to do. So that's how we get stuff out. That's how we print things. What else is there to say about that? The other kind of things you can print are strings. We haven't really talked so much about strings yet, but if you print a string, it'll remove the quotes before printing the string. It'll also strip out some other stuff, but we don't need to worry about that today. But the point is it'll turn it into a form that's sort of ready to print. And so if we take our mu editor program here and we put a string in here, like 3 plus 5 equals, and then we put 3 plus 5, now it's going to print 3 plus 5 equals, and then it's going to print on the same line 3 plus 5. There'll be a space inserted here between the two things, and then when it's done, it'll go to the start of the next line. So if I run this, it will say on the output 3 plus 5 equals 8, which is a true statement. But notice that the double quotes on the string have gone away. They've disappeared. So that's how you can use it with strings. Yeah, this is interesting because this is sort of the standard way that a program shows its work when it's done. And an interesting question is sort of, well, functions or expressions, they're supposed to return a result. Does the print function itself have a value? And it turns out that it does have a value. It's just a weird value. So let's try that out and see what happens when we try it. I'm going to say print hello. And the print function then must return some value because it's a function, and we'll print that. And what you're going to see, as you might guess if from the lecture we talked about previously, is that the value of print is going to be the special value none. So this inner print prints the hello and goes to the start of the next line. Then this outer print prints what the inner print returned. Looks like the inner print returned none, and none is a weird value. If I just type none at the command line, it doesn't even print it back. It actually evaluates it, it just doesn't print it back because that's what none does. And that's why when I say print like this, I get a new line because I didn't give it anything else to do, and I don't get the value none printed, is because none isn't printed at the command line. So things are a little weird, but that's the print statement, and it's going to be an absolute thing you use all the time in your programs. You'll be using it quite a bit. Let's talk about input. So what about going the other way? I mean, it's not very useful to write programs that just you tell it what to print. That isn't generally a particularly useful kind of program. We'd really like to get input from the user, and for that we have another function called input. It turns out input returns a string, so you have to convert it to a number, but we can then type convert it to a number, and that works out okay. Let's take a look at that here. Let's say I'm going to put it like this. We're going to use a variable. We'll talk about variables on Thursday. So what we're going to do here is first input. Darn it, I didn't mean to set a breakpoint there. We're going to first input a value. X equals the output of the input function. But like I say, that's not going to be a number. If I try to run this program the way it stands, it will run nicely enough. It's now waiting for me to type something. So I type 7. And it says type error, can only concatenate int string to string, not int, which is a really confusing error message, like most error messages you get out of computer programs. But what it basically says is that input returned a string, and then you tried to add that string to the number. Python is not excited about adding strings to numbers. So how do you fix that? Well, we're going to tell it, turn that string into a floating point number by using the float thing and the float conversion function. And so that float conversion function takes a string in, takes anything in really, and turns it into a floating point number if it can. And so now we've got a program that's probably more useful and probably does more what we want. So let's try that. 7, now I hit return and it says 7 plus 5 is 12. You notice that I told it to be a floating point number, so it's going to show it as floating point. If I ask for only integers, then we'll stop it and run it again. And now when I say 7, it's going to say 7 plus 5 equals 12. The problem with that, of course, is that if I now run it and say 7.2, well, now it fails. It says, you know, 7.2 isn't really an integer, and you were trying to turn that string for 7.2 into an integer, so now you're in trouble. Sorry, you can't do that. And so that's why I chose float, is because it's a little more flexible, but it's a matter of taste. You absolutely can choose either depending on what you're trying to do. Maybe you want it to be an error to input fractions. For example, you're counting something. So that's input and output right there. It's really common to, the input can take a prompt string. So if I put a string in here like this, question mark space, then when I run the program, it won't just silently wait for me to type something. It puts a question mark here saying, and a space. Usually you want a trailing space on the end just to make some room so that you can see what's going on. But now it's waiting for you to type a 7. So prompt strings, those are a useful thing if you want some message to be printed before you do it, before you take the input. So the input function isn't really a function. It's kind of like a function, except its input is the user typing at the keyboard, not anything that happens inside the program. The print function is a function that takes an input and produces a thing, but its side effect, the thing that it does on the side, which is to print to the user, is really the important thing about it. It's pretty typical to want to, like I say, to sort of do this whole thing where you split the program into 3 phases. In the first phase, you get your inputs. In the second phase, you compute, you do your computations, and then in the last phase you print your results. And it's often a good idea to do them in that order, to put the input at the beginning and the printing at the end, just so that it's clear what's going on. What you're going to find as we write larger and larger programs is that this stuff in the middle, the computation, is going to be 95% of the code. This setting up the input and printing the output's not going to be a big deal, and you really want to sort of isolate it so people can look at it separately. So that's input and output. That's how you do it. Let's talk about one more example real quick. So I have here a program that is an implementation of exactly what we talked about previously, which is converting Fahrenheit degrees to Celsius degrees. And what you're going to see here is the same kind of structure we just saw, because now the program, we want it to be able to input and output sort of arbitrarily. And so what you see here is that we got our input statement. It's got a prompt. Notice the prompt even has a degree sign in it, which is kind of cool. You can learn how to type that on your computer by using some kind of compose key, or you can copy it from somewhere. So I have an input prompt. I'm going to take that input and turn it into a floating point number, and that's going to be in my degrees F variable. Some things to notice. These are comments. We haven't talked about them previously, but they're kind of important. Really, every program should start with a description of what it does. Really, the next line in every program should be the author and at least the year, so that you know when it was written and by who. Those are really important things to put in the start of your code. And this little hashtag here, this little pound sign, Everything after the pound sign on the line is just ignored by Python. It couldn't care less what you put over there. Only I care. I care because I want to be able to read it. So these are what are called comments. They're readable by human beings, but ignored by the computer. And so you put the one-line comment that's what your program does, the one-line comment that's who you wrote your program and when. And you'll notice there's one more comment down here. I had to look up, because I'm American, how you do the conversion from Fahrenheit to Celsius. So I put a little comment here that said, well, this is where I looked up. This URL is where I got my conversion from Fahrenheit to Celsius. And that's important. That's how you avoid plagiarism, is by crediting things when you find them out. I used somebody's formula that they told me, so I gave them credit for that formula. And it turns out the formula is the same one we were using in class before, 5/9 times the Fahrenheit degrees minus 32 is the Celsius degrees. So we have the same pattern we had before: input, computation, output, and again, the output has this nice little degree C in it. And if I run it, I will find out that 65 Fahrenheit is 18.33333 bunch of 3s 6 degrees Celsius. Well, you might be suspicious about that 6 out there, and you really should be suspicious about that 6 out there, because what that is a rounding error. It's floating point numbers aren't always all that predictable, and especially down in their last digits, they're really kind of unpredictable unless you know exactly how they work. And so this is just essentially getting it wrong. As you might guess, the real actual correct temperature is 18 1/3 degrees Celsius, but there's no way to have 1/3 of a degree Celsius as a fraction, as a decimal fraction. And so instead we have to print it out like that. And like I say, the computer even screwed up a little bit, but to some reasonable number of places, this is 18.3 degrees or 18.33 degrees, and that's probably as close as you need for most purposes anyway. So there you have it. Simple little program. You run it, it produces an answer. If you want to compute the Celsius temperature for a different, or centigrade, whichever you prefer, temperature for a different Fahrenheit temperature later, let's say it's 80 degrees, well, that turns out to be 26 2/3 degrees Celsius. That's programming in action. Now you have a program that actually does something vaguely useful. So that's that. And yeah, that was a pretty fast run through of a pretty complicated concept. Hopefully, you'll get used to this just the way you get used to everything, which is by experience. That's how things go. But the good news is now I have this not quite entirely useless program. If I want to be able to conveniently add 5 to things, I can just run this program and give it a number and it will add 5 to it. That's its job. And so hopefully that was helpful. Thank you very much for listening. And we will chat again soon about another topic, I'm sure. In the meantime, please stay safe and well out there during these difficult times.